All right, performing 5.5 will split up into two parts. First part deals with performing function operations. This is pretty cut and dry and pretty simple. You've got to be able to add, subtract, multiply, and maybe divide. Just depending on whenever you divide, you may just have to stack two functions on top of each other. So if I have 3x times x to the third plus 2x, what am I going to do with the 3x to everything inside the function? Or inside the parentheses, rather. I'm just going to distribute and multiply. So all I'm going to do is take that 3x and multiply it to everything inside, and I'm going to get 3x to the fourth plus 6x squared. Same thing with 2. I have 14x over negative 2x to the 7th power. What can I do with the 14 and the negative 2? I can simplify them or divide. So the 14 and the negative 2 is going to turn into what? A 7. 7 is going to be on top. Now, from what we already know, what if I have x on top and I have x to the 7th on bottom, how many x's do I have left over? 6. Where are those 6 at? On the bottom side. So I'm left with 7 over x to the 6th power. Now, in this case, since it's with a quotient, what is the one value that x cannot be? What can I never divide by? Or I'll get an error. X can't be equal to 0. Okay, because if I have 0, if x is 0, then it's going to give me an error. Same way on 3, I have x to the third over x squared minus x. So I need to simplify first. So I'm going to have x to the third on top, and I'm going to have x times x minus 1. So if I have 3 x's on top and I have 1 on bottom, the only two that I can simplify here are on the outside. I can't do anything with what's inside the parenthesis. So if I have x to the third on top and I have x on bottom, what am I left with? What am I left with on top? X squared on top, and then, so that's gone, and then that just turned into a 2. And then I still have the x minus 1 on the bottom side. Now again, it's finished as a quotient, so the bottom side can't be equal to 0. That doesn't mean x can't be 0 in this case, but what is the one value for x that will make the bottom equal to 0? If it's x minus 1, what's the only number? 1. So x can't be 1. Now, whenever we talk, and we'll skip over 4, 5, and 6 because that's just multiplication, or then just distributing that power. So whenever we talk about operations of functions, okay, and if we have two functions, or really any sort of operations of functions, we have more than one function. 2, 3, 4, whatever. Whenever we add, there are two different ways that we can read this, okay, or two different ways that it can be written that mean the exact same thing. It may have f and g as your two functions together with an addition. Okay. We're going to add the two functions because it is addition. You can also write it to where those two values are separated, or those two functions are split apart and added that way. But you're still going to do everything the same. Second one then is subtraction. Okay, whenever we subtract, it'll either be written where it's f minus g of x, or it'll be f of x minus g of x. Both of them, again, mean the same exact thing. Multiplication, f times g of x, or it can be written as f of x times g of x. And then division, f divided by g of x, or f of x divided by g of x. Division, to be perfectly honest with you, is going to be the easiest one to set up because you're going to put whatever comes first goes on top, whatever comes second goes on bottom. The big disclaimer is down here at the bottom where it says that the domain of a sum, a difference, or a product quotients consists of x values that are in the domain of both functions. Additionally, the domain of the quotient does not include the x values in which g of x is equal to 0. So basically what we just talked about on 2 and 3, the bottom side of my quotient, the denominator, cannot be equal to 0. That doesn't mean x can't be equal to 0. That means that the whole part of the function. So if you have to factor anything out, you have to factor things out. So like on the examples where I have f of x is equal to 5x and g of x is equal to x plus 2, and it says f divided by g. So what is the one value down here that's circled? What is the one value that x cannot be, that should be added on to right here? X cannot be negative 2. It can be everything else, but it can't be negative 2. Second kind of disclaimer is here on the subtraction problem. Biggest mistake that gets made is, or if there is going to be a mistake on a problem like this, the one thing you do not want to do is go 5x minus x plus 2. Do not do this. Now, why is what I have written there incorrect? What didn't I do? I didn't distribute the negative. I only gave the negative to the first term and not all terms. Okay, you have to make sure, so if you need to put it in parentheses, put it in parentheses. That's fine. Or if you need to go ahead and give everything and change the sign, do that. But if you're going to make a mistake on a subtraction, that's probably where it's going to come from. Is whatever that second or third term is, you don't change the sign or you don't distribute that negative. Okay, so if there's going to be a mistake, that's what it's going to be. So I would go ahead and make sure you group whatever is second, especially if there is a negative sign. So if it says, let f of x equal to 3x to the third minus 2x squared plus 5, and g of x is equal to x minus 3x squared plus 4x minus 2. Find f minus g and then state the domain and then evaluate the difference when x is equal to negative 2. So you have to do three things. You have to rewrite the function of them being combined somehow, some way, or by its operation, in this case subtraction. Then you've got to tell what the domain is. A large portion of the time, your domain is just going to be negative infinity to positive infinity or all real numbers. And then you just have to plug and chug negative 2 in this case back into your function. So if I have 3x to the third minus 2x squared, and I'm going to go f minus g. Okay, all I'm going to do, I'm just going to rewrite this. Nothing's going to change. I'm going to have 3x to the third minus 2x squared plus 5. Now, again, it is subtraction. So everything here, either I need to change all the signs or I need to have a negative and I need to put everything in parentheses. It does not matter to me what you do. If you want to put it in parentheses or you want to look at everything and automatically change the signs and then go, do that. Okay, so if I have 3x to the third, nothing's going to change on the front side. I'm going to have negative x to the third plus 3x squared minus 4x plus 2. Combine like terms. So 3 minus 1 is going to give me 2x to the third. Do the same thing with the squareds. I'm going to have plus, if you want to have plus 1x squared, that's fine. I only have 1x, so minus 4x. And then 5 plus 2 is going to give me plus 7. So there's the function combined or used with the operation. There are no restrictions here. Okay, so my domain. So the second part of it was to find my domain. Well, the domain, negative infinity to positive infinity. Or if you just want to say all reals, you can do that. And then plug in the negative 2. So all I'm going to do is just plug and chug. I'm going to have 2 times negative 2 to the third plus 1 times negative 2 squared minus 4 times negative 2 and plus 7. So negative 8 and 2 is negative 16 plus 4 plus 8 plus 7. So 15, 19 is positive, minus 16 is going to give me a positive 3. Now, on ones like the second one and the third one, where you have stipulations with each function, I would go ahead and write that down before you start. So like for f of x with 3 times the square root of x, what kinds of numbers can x not be? If it's underneath the radical, if x is underneath the radical, what kind of numbers can x not be? Negative. So that means for, like, I would kind of off to the side, if I'm just dealing with my f of x, as far as my domain, you know, it's got to go from 0 to positive infinity before we even start. Same thing with g of x. Since I have a square root, it's the same stipulation. So if I have the same stipulation that my domain has to go from 0 to positive infinity, then know that kind of going in before we, in this case, add. Okay, so if I'm going to add, all I have to do is take, not draw that line, is take 3 times the square root of x plus negative 10 times the square root of x. What's 3 plus a negative 10? Negative 7 times the square root of x. And you're finished. Some of these are going to be that short and that simple. Now, I still have to write my domain. My domain didn't change, so I'm just going to use either of the ones that I have over here, that my domain has to be from 0 to positive infinity. And then the last step is plug in x equal to 4. Well, if I plug in x equal to 4, if I have negative 7 times the square root of 4, square root of 4 is 2, so I have negative 7 times 2, so negative 14. Don't overcomplicate this, because it's not complicated. Okay, I promise you. The biggest thing is just taking your time and paying attention to what you have to start. Even on like the last one, do you have any stipulations here? Do you have any restrictions for x squared? X can be anything, right? what does x have to be here? Yeah, so for g of x, my domain has to go from 0 to positive infinity. It has to be, you have to check everything before you even start. So then if I just multiply x squared times the square root of x, I literally am going to have x squared times the square root of x. All I have to do is combine it. I can't do anything else with it. Hey, I just have to leave it like this, and I'm done. That is my function. That is it simplified. Then, what's my restriction? What does my domain have to be? Well, it has to be from 0 to positive infinity. That didn't change. And then all I'm going to do is plug in 9 into my equation. I'm going to take 9 squared. I'm going to multiply it by the square root of 9. I'm going to get 81 times 3. And I'm going to get 729. Excuse me, 243. My fault. Not multiplying by 3, not 9. Same way, even if it's division. Okay, so like on 2, I have 3x. I have for f of x, and I have g of x is equal to x to the 1/5 power. So the only stipulation, if I'm going to multiply, it's an odd root. So again, if you need to turn this into the 5th root of x, and you need to write it this way, that's okay. Now, I will tell you on ones like this, it's going to be easier to leave it as a fraction, because especially if you're going to multiply or divide, you're going to add or subtract here. So there's no restriction except for like on the division. I'm just going to multiply. Whenever I do the division side of it, whenever I have f over g of x, all I'm going to do is I'm going to take 3 over x, and I'm going to take x to the 1/5 power. Now, before I start, what is the one thing that x can't be on that bottom side? Can't be 0. So my domain has to go from, or it's really just anything where x can't be equal to 0. Okay, if you just want to put that, that's fine. Then it just becomes a division problem. What number is up here? It's just a 1 there, right? So what's 1 minus 1/5? 4/5. Remember 1, we just have to change it to where we have common denominators. Okay. Then it would just say, and then it says to plug in for 32. So evaluate for 32. I'm just going to put 32 to the 4/5 power. And again, that's something you can just type it straight into the calculator, because it's going to be a nice, neat number. Because the 5th root of 32 is just going to be 2. I'm going to take 2 to the 4th and get 16, and take 16 times 3, and I'm going to get 48. Is all that it's going to do. Okay, they're going to give you numbers that are going to be easy to deal with and easy to work with.